Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today I'm pleased to welcome Dr. Mohammad Modarres. Dr. Modarres is the Nicole Y. Kim Eminent Professor at the University of Maryland's A.J. Clark School of Engineering and the Director for the Center of Risk and Reliability. Under his leadership, the university's Reliability Engineering graduate program has grown to become an internationally recognized center for research and education and has graduated over 400 masters and PhDs in risk and reliability. Dr. Modarres received his MS in mechanical engineering and his PhD in nuclear engineering from MIT. He is a University of Maryland Distinguished Scholar Teacher and a Fellow of the American Nuclear Society. His research interests include probabilistic risk assessment, physics of failure, reliability analysis of complex systems, and, most recently, prognosis and health management. He has served as a consultant to several government agencies, private organizations, and national laboratories. The third edition of his book, Reliability Engineering and Risk Analysis, A Practical Guide, was published by Taylor and Francis in 2017. Dr. Modarres, welcome, and thanks for joining us.
Thank you for inviting me.
It's a great honor to have you here today. Dr. Modarres, some of our listeners may not know much about the Center for Risk and Reliability at the University of Maryland. Can you tell us a little bit about the history and current mission of the center and maybe some of the degree programs that are available?
Yes, the Center for Reliability, Risk and Reliability was established in 1985, and it was the original umbrella center or umbrella organization to gather the expertise in risk and reliability analysis at the School of Engineering at University of Maryland. And one of its missions was to also at the same time to look into establishing an educational program in reliability engineering. So we were surprised at the time that there was a number of expertise in different engineering schools in reliability engineering and risk analysis at that time exist in various areas. And we kind of at that time embarked on developing a curriculum in reliability engineering also, one of its first kind. So we developed this educational program which offers master, as you noted in the introduction, master and PhD in reliability engineering. Originally, it started under the nuclear engineering program for up to 1989, and then from 1989, it became an independent program that offers its own degrees in these areas. It probably was the first of a kind in the United States offering degrees specifically in nuclear, in reliability engineering and previously, there had been programs in reliability engineering, but they were under mechanical engineering or other programs.
Sure.
So generally, this was one of its first of a kind that actually had its own curriculum. And it became very, very successful. It's been in existence since then. We had a celebration of our 25th year of existence. But 4 years ago, and it was very successful. So we have had the traditional students coming from bachelor's degree to get a master's degree or PhD, and we have also a professional program that hosts people from different companies or organizations to seek degrees in reliability engineering. So that was the genesis of the center itself, and of course the other mission of the center was its develop a research, being a research arm of the university, kind of collect all these expertise from different departments and apply for different grants and research projects from various areas of the discipline, being a systems engineering type, systems type question. Reliability could answer questions in all kinds of areas: space, defense, civil aviation, nuclear energy, petroleum industry, medical, information systems, civil infrastructure, all kinds of areas. So and we've been involved in all of these areas under this center, drawing from about um, uh, 10 or so faculty members who are permanent members of the center, and another 10 who are, affiliates with the center. So,
I think that's one of the real strengths of the center is that it is interdisciplinary, and that you really can take a systems engineering approach. I think that's fantastic.
yes, so that has been, and we are actually have people we have a systems engineering program also at the University of Maryland who are collaborating with the reliability engineering very closely, and so it's been really a very wonderful experience for us, and to the point that some other universities are kind of copying our model, both in the
Sure.
United States and also overseas.
I'm not surprised at all. Dr. Modarres, it seems like a lot of engineers today graduate with just a very, very limited exposure to reliability engineering in the classroom. They learn mechanical engineering or electrical engineering or nuclear engineering, but they don't really spend much time on reliability engineering. They're expected to learn reliability engineering sort of on the job. Can you talk a little bit about the value of pursuing an advanced degree in reliability engineering?
Sure. I think there is definitely a lot to learn on the job. The kinds of topics, and you could be very successful indeed, still being a well-rounded mechanical engineer or electrical engineer, and gain reliability experience on the job. So there is a platform there to learn. There are quite a bit of courses and short courses that people usually attend. So that has been traditionally existed and still being used. The value of education, on the other hand, is a totally different in a sense, because it's education in reliability engineering would be kind of a stepstone into getting into a more comprehensive and more well-rounded person in the subject area. The person will come with a significant amount of tools and techniques that they would learn during their course of education, and they can use those tools and techniques to its maximum usage once they come into a job. It doesn't say that they are having completely they can do the job at their best, but they have still to learn some experience. But they do have the tools that makes them much more efficient. They can actually do a far better job because of using these kinds of different techniques that they have in their inventory. So we have found that people who really go through our education, they become lifetime reliability engineers, and they can adapt to the area very fast. They would never leave the jobs. We found that reliability engineers who actually get their experience through the job, sometimes they stay in that area for a very long time. They stay in the narrow area, but sometimes they also switch to other areas and they change. So there is a more turnaround on those kind of expertise as opposed to people who go through an education in reliability engineering.
Interesting.
So we find actually our graduates have made a significant amount of impact in the industry. The 400 or so graduates at the time that we started this program, the mostly the approach to reliability engineering was doing, for instance, data analysis. Getting some data, doing essentially reliability validation or reliability analysis from the traditional 217, for instance, approaches and so on.
Yeah.
Very standard type methods. But the graduates that came out of the program, they started actually introducing more modern techniques of big data analysis, more sophisticated computational methods, Bayesian analyses, physics of failure analyses, the kinds of things that actually, now that you go to RAMS conferences, you start seeing these more modern techniques, more advanced techniques coming and finding its way to reliability engineering. So
I assume more modeling techniques also.
Many more modeling techniques, especially in systems analysis, systems technique, both in modeling of the physics of failure models, statistical models, probabilistic models, logic-based models, learning methods such as the Bayesian network type belief networks. A lot of these machine learning has become more recently made its way into reliability. So the models of learning from data, unsupervised or supervised learning, all of these are things that a graduate from the program would come out knowing rather well. And they may or may not use it when they enter a particular job, but they would, if whatever they would do in that job, they would do it at their best because they have.
It really sounds like we're talking about the transition from just running tests and collecting a lot of data versus being more actively engaged in the design process.
And that is true. There has been a more significant intrusion of reliability engineering during the design process. It used to be an afterthought, essentially, originally when the ideas were coming up. So we were, designers would design a system and they would say, okay, reliability engineers would just kind of evaluate that and then see if they meet the requirements, let's say a given mean time between failure or mean time to failure requirement. That was basically the reliability job.
That's right.
These days, these are completely changed to a more proactive involvement of a reliability engineer from the beginning, when only at the inception of a design is in place, all the way to the design being make it in the field, and they would stay from the point of the beginning to all the way to the end.
Right.
And so that has been the case for reliability engineers. Yes.
Dr. Modarres, I'm curious about your students, your typical students. I know it's very common for experienced, business people to go back to school to get a degree like an MBA. Are you finding more students who are experienced engineers who have a career, who are interested in returning to school? And I guess I'm wondering if they're getting support from their employers to pursue an advanced degree.
Thank you. This is a very good question, and the answer is definitely a yes answer to this. And originally, when we started the program, our students were typically the students who would go from undergrad, or maybe after a couple of years, they wanted to change their career. they would come to the university, and then they get a degree because they wanted to kind of change their career.
Right.
These days, we started seeing actually more and more companies recognizing that they really do need to re-educate their human resources and engineering resources, especially in the areas of reliability engineering. And so nowadays, more than half of our students are actually people who are coming from or sponsored by their companies or government agencies.
That's fantastic. That's great.
So we find them in two different groups. One group are the ones that actually get funding from their agencies, and they spend their time here on campus fully. They get their degrees, either a master or a PhD, and then they leave back to their job. Of course, they have some relationship with their company that I guess they would get this possibility. Often is the case that they have to go back and work for their company for a while.
Sure.
Or their organization. So we get people in that category from more so from government agencies. So we get from Navy, NASA, or we get people from Nuclear Regulatory Commission, Department of Energy, and also a couple of European countries, and especially Australian defense. We get students who are coming past 10, 15 years, constantly 1 or 2 or 3 sponsored by these organizations. They spend 2, 3 years. NRC, for instance, gives 3 years scholarship to students, to their employee, to come here, get a PhD, and they go back to NRC. And they mostly come here to do risk analysis.
Right.
And they collect. The good thing is a win-win situation, because they get they collect their full salary, and at the same time they get an education. And the employee gets guaranteed that they will go back to work for them and get benefit of them when they return.
Right.
So that was one category, people who are actually on campus. We have a second category, and these are people who are mostly in the master's program, rarely in the PhD. These are people who actually get their education through online connection to our courses.
Right.
And we get at least 15 to 20 students a year on the program. So it takes them about 2 or 3 years to finish.
Sure.
They take like one course a semester, and our courses are online. And once when we offer a class in the classroom, it changes to a video, and that video becomes immediately available to those off-campus students. They can interact with the instructor through the internet and through the website of the course. There's a lot of discussion mediums, and it's been really, really successful. And I can tell you one thing, they do as good, and often, at least in the classes I've been teaching, as good or sometimes even better than the students who are on campus.
Well, and they gives them, it's obviously a lot more convenient for them, especially if they're working people.
And it is very convenient. The reason is because they would be essentially, when they get that video, they can they still have to go by the speed of the class, which is 1 week. Every week we have one of these classes, but then they can watch that video and study it anytime they want. They don't have to go 9 o'clock to the class. They can watch that video of the class on Saturday or in the evening.
Exactly.
So that gives them freedom, but still they have to do the same homeworks, the same effort, and all that.
Sure.
Yeah, and they do all very well, and we have had at least 200 graduates of this program online who have been outside. And yeah.
Dr. Modarres, this opportunity to work with experienced engineers who are coming back to school after some time, perhaps in mid-career, and maybe, bringing some real-world problems from their current employer, whether it's a government agency or a business, that's got to create some tremendous opportunities to collaborate with
Absolutely.
in industry. Unfortunately, we don't have time to go into a lot of detail on this, but I wonder if you could give us some examples of
Yes.
some of the projects that your students have worked on that have had some big impact on our understanding.
All our courses have projects at the end. They have class projects, and students usually bring in really real world problems from outside, people who are really on the companies. And eventually, these problems, we as instructors also need to learn. We also, when we teach, we learn at the same time.
Good point. Good
And
point.
we learn from them these problems, and invariably, these problems will make it to our notes and examples that we would offer in the future classes. So I can at least tell you that if not 10% or 20% of our examples of the class actually come from the experience of the students from previous classes.
Sure. That's fantastic.
Yeah, they have been. So, I can provide specifics, but there are, more of these existing.
No, that keeps it alive, right? It means that we're really using our new understandings to continue to build the program.
Absolutely. And it makes a synergy in the class and brings the class up to date with what's going on out there in the field. So we are not really in the ivory tower doing presentations. Yeah.
Right. I would also expect, I don't know what kind of partnerships you might have with people in industry, but do you see examples of projects being brought to CRR for investigation?
Of course. Through these students, you mean the students who were part of the program, or you're just generally outside?
Well, either way, I wonder if businesses are coming to CRR asking you to do some research in certain areas.
Students are really big resources for us. When they go back, they know our capabilities, and they've been really very helpful promoters of our capabilities when they go back to their industry. And we do get quite a bit of funding from these people when they go back to their companies and work. So we do have CRR's most of its research funding, which essentially also funds our on-campus students for scholarships and assistantships, mostly comes from the government agencies, essentially.
Yes.
Because they have these kinds of the big problems that we try to solve, and it gives us plenty of time to solve them. Because a PhD takes 2-3 years, and we cannot interrupt it. Mostly the problems of the corporations are shorter term. It's not to say that we don't do those. We do some of it, but they are more on the shorter basis. So we do have cooperative agreements with USNRC, Office of Naval Research,
Yes.
NASA, USDA, with some other research centers such as the Norwegian Institute of Technology, with the Department of Defense of Australia, and so on. With companies here, we also do have ongoing relationships with Wiley Corporation, ARES Corporation, Corning. We've been doing, these are just to name a few. We do have more shorter term efforts with the companies. As I said, much longer term relationship with the government organizations.
Sure, that makes sense.
Yeah.
Dr. Modarres, this has been great. Thanks so much for joining us today.
My pleasure. Thank you for inviting.
That was Dr. Mohammad Modarres, Director of the Center for Risk and Reliability at the University of Maryland in College Park. For more information about the Center for Risk and Reliability, please visit crr.umd.edu. This is Tim Rogers. Thanks for joining us.